Hi, I'm Ramyani, and I'll be talking about the effectiveness of info art as a peripheral display. Ubiquitous computing today enhances everyday computing and facilitates constant interaction with computers, the digital world, and our physical environment. There has been significant work in the area of information displayed through ambient displays. With the many devices we own, peripheral awareness from secondary devices is a topic worth studying. Furthermore, recollection of information which is presented in a visually captivating way is often better than when presented in more primitive forms such as text. This has been a major focus in information visualization techniques. I'll be referring to this information art as info art throughout this presentation. Starting with the background of research done in this area, one great example of information art that I draw heavy inspiration from is InfoCanvas by Miller and Stasko. The main goal of InfoCanvas is to tackle the issue of monitoring multiple pieces of information on the web and how distracting this can be. InfoCanvas is described as a highly personalized, elegant, aesthetically pleasing, abstract display which helps users peripherally be aware of important information. The display itself is on a wall-mounted canvas like a piece of art. The next paper is titled Is a Picture Worth 1,000 Words? And it focuses on evaluating the effectiveness of peripheral displays of information. It compares InfoCanvas to other more common text-based and web-based displays of information. They set up controlled experiments in a lab setting where participants are made to look at the display for 8 seconds and then tested on how much information they recall immediately afterwards. The participants demonstrated higher comprehension and recall of information presented by InfoCanvas despite having to learn additional graphic representations. This is seen in the results here. The study suggests that there are benefits for comprehension, especially in brief glances at a display, by representing information in a highly graphical or stylized manner. However, in this study, participants give their full attention to the info art display, not testing its effectiveness as a peripheral or ambient source of information. This next one evaluates information display in notification systems. They study the balance between interruption, reaction, and comprehension using secondary animated displays in a dual task setting. The primary task involved hypertext browsing, which resembles common computer activities. Participants had to find specific information, enter it into a connected box, and proceed to the next task. At the end of each round, the participants were asked awareness questions that required recall of information shown in the secondary display. Now, these works led me to formulate my research question, which spans across these areas and tries to fill in some gaps. That is, how does recall rate vary between a text-based display and an info art display presented as a peripheral source of information? To test the effectiveness of an aesthetically pleasing info art display, the first step is to develop such a screen. I first sent out an informal survey to collect ideas on what kinds of information people like having access to on a day-to-day basis. The results included some data points such as weather, news, traffic, stock prices, and health data. The survey also had questions that asked respondents to select which visual aspect they'd associate with some of these information points. For example, temperature was most associated with color, whereas step count was associated with position. So keeping these factors in mind, I developed this info art screen. Let me break down the elements and explain what they each represent. Firstly, the billboard in the image is going to show a news headline. The presence of a squirrel in the image means that a delivery needs to be picked up. The bird's position on the screen shows the step count of the individual who's using this display. If the bird reaches the rightmost edge of the screen, that means that the step goal has been reached. Furthermore, the number of birds present refers to the calorie goal. So if from one bird it becomes 5 birds, that means that the user has reached their calorie goal for the day. The car at the bottom of the billboard represents the battery level of the phone. If it's at the left edge of the billboard, that means low battery. The color of the car represents the traffic on the way home. If it's green for less traffic, yellow for moderate traffic, and red for heavy traffic. The position of the sun and the color of the sun represent the time of day, changing from morning to noon and noon to night. The position of the cloud with respect to the mountain represents a stock price that is relevant to the user. So if it's at the highest point of the mountain, that means that the stock value is higher than what it was yesterday. If it's in the middle, it's the same as yesterday. And if it's at the bottom, then it's lower than the value that it was yesterday. The color of the car represents the temperature outside. So as you see here, it goes from the spectrum of very cold to very hot, and the color changes from blue to red. Also, the object present within the vehicle represents the weather conditions outside. So these have different symbols representing sunny, thunderstorms, rains, etc. So the final info art display might look something like this. Now, in order to design an experiment that evaluates the effectiveness of this screen, I needed a control display as well. This is a screen portraying the same information as the info art display, but in a text-based format. Both screens show exactly 10 pieces of information. Now, the experiment itself had to include a control group and an experimental group. The control group was given the text-based display, and the experimental group was given the info art one. As this was a pilot test, recruitment was just done by word of mouth. However, I made sure to have an equal number of participants, that is 5 people, in each group. Before beginning the experiment, the participants were asked to fill out a consent form, reaffirming their voluntary participation and giving me permission to use the results of the study. They were then given a detailed explanation of the screens they were going to be looking at. For the control group, I showed them what the mobile screen will look like and pointed out the different kinds of information. For the experimental group, I showed them the legend that maps the image elements to the kinds of data. I asked them if the display was clear and made sure they asked questions if they had any doubts. To evaluate the capabilities of the two displays as peripheral sources of information, the experiment needed to be in a dual task format. The primary task given to the participant was to browse through a Wikipedia article on a primary device, that is, a laptop. The chosen article that I gave to each participant was about Australiformis, a parasitic worm from Australia. I got this by looking up Wikipedia's featured article of the day. They were allowed to scroll through this page and click on any hyperlinks they desired at their own pace, acting as if they were browsing Wikipedia on their own time. Now, the second device was a phone screen with the respective information displayed on it and kept next to the laptop. The participants were asked to interact with the wiki page and also glance over at the phone screen throughout the duration of the experiment. Participants were given 4 minutes for this dual task. Since the two tasks were unrelated, it's expected that the participants would use a discrete split of their full attention to attend to both. I did not place any indication of priority or urgency on any aspect of the experiment. Since both tasks required a moderate level of cognitive processing, it can be considered a fair setup to test ambient information consumption. For the sake of variety across participants, I developed 3 such displays in InfoArt format and 3 equivalent text-based ones. In order to test how much information was gleaned and retained from the phone screen, the participants were made to do a recall test. This test was on all of the data points represented in the display, and it was taken immediately after the task. These were mostly multiple choice questions, but the news headline had to be typed in. The score calculation involved awarding 1 point to every correctly answered question. The news headline's accuracy was calculated using a sentence similarity model and was considered correct if it was over 70% similar in meaning to the actual headline. After the experiment was done, I asked participants in the experiment group to fill out a form to collect feedback on the InfoArt display and their thoughts on it. After collecting all the data from the 10 participants, here are the results. I calculated the average score secured by the control group and the experimental group. From these experiments, the recall rate is higher for the experimental group at 76% than it is for the control group, which was 64%. The performances also varied across the displays as seen in this graph. Those who saw InfoArt Display 3 performed better than those who saw Display 2. This might indicate some flaws in the design of the system, as different values should not affect the recollection rates from the image. This brings me to the limitations of the study. Firstly, the graphics may have been limiting in the sense that the data points were not customizable and neither were the visuals. As a result, some of the visual mappings might have been unintuitive. Furthermore, the colorfulness or flashiness of the InfoArt display may have unfairly drawn attention or distracted from information. Secondly, the period of observation was very short for the sake of the study. To determine whether such a display would truly work in one's day-to-day technology use, prolonged exposure and monitoring is required. The primary task was simply an imitation of something users might be occupied with. However, due to the lack of personal value of the Wikipedia article, everyone gave it varying degrees of attention, affecting the recall rate, but it can be argued that this condition was the same across both control and experimental groups. Lastly, the text display is quite primitive. Most current displays of information have a more standardized design, including icons and some graphics. Having said that, the findings from this study are interesting. These are some quotes taken from the experimental group participants. They said that they'd certainly use such a display as it is visual and concise and that it would make a great lock screen. They thought it was cute and could be used as a wallpaper. Some of the points of improvement were that certain representations were not intuitive, like the color of the car on the billboard representing traffic, while its position was battery level and this was confusing. Furthermore, it's something that requires some time and interaction to get familiarized with. To conclude this presentation, I go back to my research question. How does recall rate vary between a text-based display and an info-art display presented as a peripheral information source? We learned from these experiments that recall rate for an info-art display is better than a text-based display when presented as a peripheral information source. With the large number of devices and screens around everyone today, it's important to have certain personal data be delivered in an efficient, customizable, and impactful while peripheral way. This shows that there is value in developing more personalized info art displays if it means higher retention of information. Also, there are definitely avenues for more research work in the area of graphic representations and which associations are most intuitive. There is no one size fits all solution, as these associations depend on factors such as culture, nationality, age, etc. I'd like to see more work done to develop an effective and pervasive info art display that I can download on my phone. That's the end of my presentation. Thank you.